Another example. Let's find the intersection points. So I set the two functions equal to each other. And I'm going to solve by factoring. So I bring everything to the left. What does that give me? Well, the 3's cancel, which greatly simplifies my life, because the left-hand side is now left-hand side. Ooh. Yeah, left-hand side is now, oh wait, is this reversed? Ooh. This side is now easily factorable. Take an x out. And solve for x. From here I get x is 0. From here I get, well, let's factor it further. From here I get two answers, 2 and minus 2. Okay, so that yields a number line like so. And I'll do some test points to figure out who is bigger where. This is a straight line. G is a straight line. F is some curve. So a very non-literal picture of what's happening is that you have a cubic kind of maybe going like this, or maybe it's going like this. I'll fill that in just a second. Let's finish this diagram here. So just choosing test points. If I plug in -3, what am I going to get? I'm going to get 0 here. And I'm going to get something quite negative for f. So G is bigger than f. If I plug in -1, I'm going to get 2 here. And I'm going to get -1 plus 3 is 2, 5. So f is bigger than G here. If I plug in 1, I get 4, and I think 1 here. Anyways, G is bigger than f. And finally, if I plug in 3, I'm going to get 6 here. I'm going to get 27. Minus 6 is 21. Anyways, f is bigger than G. Okay, so what have I found? I have found that, just checking here, yes, G is bigger than f, then it's smaller than f, and then it's bigger than f again, so G is a straight line. So it looks something like this. So G is smaller than f, then it's bigger than f, so it looks maybe something like that. Okay, this diagram is not to be taken literally. Just give me an idea of what the enclosed area looks like. F is bigger than G. F is, oh, I got it backwards, don't I? G is bigger than F. Yeah, I got this backwards. Okay, I got it backwards, right? Because here I have G being less than F to begin with, which is not what I want. Sorry for that. Even a genius like me makes mistakes sometimes. A genius such as I. Okay, so I start off big with F being left. Okay. What do I do? I labeled my diagram wrong too. Oh, I had it right, didn't I? I just labeled it wrong. So G is the straight line, and F is the curve. And G should be big enough. G should be big enough. Okay, so I had it right. I'm just trying to talk and think at the same time. Which is not good. Okay, I think I have it now. Okay, here's the enclosed area. This guy plus this guy, something like that. So from this picture you can see, you don't need this picture, but I'm just giving it to you so you have a bit more of a visual. Really, this diagram here is all you need. It tells you that the enclosed area is happening here and here, and you can set up your integral based on that. So the integral from -2 to 0 of f minus g. So again, pulling this from the diagram here, plus the integral from 0 to 2 of, now it's g minus f. And then you would just plug in these functions. Do not forget brackets. Oh boy, that's a unpleasant thing to grade when you forget these brackets here. I'm not a happy camper when I see that. And then for the second integral, we're reversing g and f. I don't need these brackets here. Oh well. It's better to have too many brackets than not enough. Okay, I will leave this to you to calculate. Should be getting 4 plus 4 is 8.